Hello grade 11s, today we are going to start looking at chemistry. So this is a chemistry topic. We're looking at atomic combinations, chemical bonding, all of those things. So this is an introduction to chemical bonding, and we're going to also recap a little bit of grade 10 stuff, but I'm also going to be introducing the new grade 11 work. So let's jump right in. Atomic combinations falls under the section called matter and materials, and we'll be focusing on chemical bonding and the intro to chemical bonding in this lesson. But before we jump into that, I just want to show you your ATPs. So this is the document that the government gives to schools and teachers, and this is what you need to know according to the Department of Education for your exams. So they show you in quite a lot of detail exactly what you need to know. They break it down for you. So you can pause the screen, you can take a screenshot of this, you can write it in your book, and you can use it as a checklist. I also have a document on my website that has this written out nicely for you already as a checklist. So you can print it and stick it in your book. But basically, this is everything that you need to know. And this is everything that we'll be covering in this playlist. Right, now, there are a lot of definitions that you need to know for this section. And by now, you should know that definitions in physical sciences, in physics and chemistry is very, very important. You need to be able to define certain terms, and you need to be able to give the important keywords in order to get your marks. Usually definitions are worth 2 marks, so make sure that you learn these. These are the easy marks in your exams, and we'll be going through each of these definitions as we go through the work. Remember, this is an intro video, so we'll be starting off with what is a chemical bond. We'll speak a bit about covalent bonds and valence electrons, stuff like that, but we will go through all of this in the videos in the playlist. Right, so chemical bonds. You should know from grade 10 already, and you did chemical bonding in a little bit of detail in grade 10. You need to know that atoms are held together in molecules and compounds by chemical bonds, okay? And ions are held together in crystals by chemical bonds. Now, if you think back to grade 10, we actually did 3 types of chemical bonds. See if you can remember what those types are. I will mention them again very shortly, but think about what they are. I give you a lot of clues over here, but this is basically what chemical bonding is. This is what chemical bonding does. But before we get into a chemical bond, I want to make sure that you understand the difference between a chemical bond, which is also called an interatomic force or intramolecular force, and an intermolecular force. There's a big difference. You need to understand that. Now, if I had to ask you to label the yellow line that you see between the O and the H and this dotted blue line over here that you also see between an O and an H, would you be able to label those lines? Do you know the difference? You need to know that this yellow line over here, this thing that's joining the oxygen atom and the hydrogen atom, that over there is called a bond. And in particular, this is a covalent bond, but we'll get into that now. But this is a bond. Another word for a bond is an intramolecular force, or an interatomic force. A lot of words for one thing, but it's important that you are familiar with all the different terms because you never know when your teacher could use what term, or your textbook, or your study guide, or your exam. So this is a bond. It is an electrostatic force of attraction between 2 atoms. It's inside the molecule, which is why it's called intramolecular. Think of intra as meaning inside. So intramolecular means inside the molecule, and it's also called an interatomic force. The word inter, think of it as meaning between. Now, if you read that again, you can see that interatomic means between atoms. Interatomic force, or an intramolecular force or bond. That's that one. Now, if that's that, what is this blue dotted line over here? It's not a bond. It's not a bond, okay? It's not an intramolecular force. It's not inside the molecule. This is inside the molecule. This is not inside the molecule. It's not interatomic. It's not between 2 atoms of one molecule. What this blue dotted line is, it is actually called an intermolecular force. And that is a whole nother topic that you'll be learning in grade 11. Intermolecular forces. It's a very important topic, and it follows this topic that we're currently doing. Now remember, inter, what does that mean again? That means between, and molecular means molecules.
So this blue dotted line is between molecules, and that makes sense because this blue dotted line is connecting water molecule number 1 with water molecule number 2. There is a difference between bonds and intermolecular forces. Don't get them confused. So here's another diagram that maybe summarizes the differences. Here you can see the CO2 molecule, and I've highlighted the bonds or the interatomic forces in green. Okay, it's between atoms. Intermolecular forces are not bonds. Another important thing that you need to know in this video is that we have 3 types of bonds. These are 3 types of interatomic forces, and I've listed them up there. You did learn about them in grade 10, but they are covalent bonds, ionic bonds, and metallic bonds. Now, what you need to remember and what you were taught last year about the 3 different types is that covalent bonds is between a non-metal and a non-metal, okay? Non-metal atom, non-metal atom. So for example, H2O, hydrogen is a non-metal, oxygen is a non-metal, or carbon dioxide, carbon is a non-metal, oxygen is a non-metal, and so on. Then we've got ionic bonding. Ionic bonding is a bond between a metal and a non-metal. So for example, something like NaCl, sodium is a metal, chlorine is a non-metal. The metallic bonding consists between or exists between metal atoms within the same metal. Okay, right. Now, you need to know the proper definitions for covalent, ionic, and metallic bonding as well. So covalent bonding, as I showed you earlier in the video, the definition is over here. Covalent bonding, over here, is the sharing of electrons between atoms to form molecules. And what I would just add in there is the sharing of electrons between 2 non-metal atoms to form molecules. It's very important to remember that covalent bonding is when the 2 atoms share. And ionic bonding, which is actually not here behind me, but ionic bonding involves the transfer of an electron or electrons from the metal to the non-metal atom, and that is how the bond is formed. So you need to know the proper definition. If we ask you to define covalent bonding, you can't just say covalent bonding is between 2 non-metal atoms. You need to tell me that covalent bonding is the sharing of electrons between atoms to form a molecule. But what is a chemical bond? The definition for chemical bond that you need to know is a chemical bond is a mutual attraction between 2 atoms resulting from the simultaneous attraction between their nuclei and their outer electrons. It's basically a force that holds the atoms together in a molecule. Now we will get into bonding and how the attractive forces work and the repulsive forces work and how that affects bond energy and bond length in another video in this playlist. But in this video, all I need you to understand is that it's a mutual attraction between 2 atoms. So if you look at the little diagram I drew over here, this represents an atom, atom number 1. We've got positive protons in the nucleus, and we've got negative electrons that surround the nucleus in the outer orbitals. This is atom number 2 over here. Again, positive protons in the nucleus and negative electrons in the orbitals that surround the nucleus. Now, basically what they're saying is that it's a mutual attraction between 2 atoms. The positive protons here are attracted to the negative electrons of the other atom, and vice versa. You can see here, the negative electrons here are attracted to the positive protons there. And basically what happens is these atoms move closer, they move at an optimal distance from one another where their energy is the lowest. We'll get to that in the next video. And then they form a bond. It's a force holding the 2 atoms together. And this is essentially what happens. Atoms collide, the outermost electrons, the valence electrons, come into contact with one another first. The positively charged nucleus pulls on the valence electrons of the other atom, as I mentioned, and this creates a force. Now, we will go through this in more detail, as I said in other videos in this playlist, but this is essentially what happens. There's an electrostatic force between the different charged particles. There's attractive forces, there's repulsive forces, and basically they find an optimal distance between them where the energy is the lowest, and that's when the bond happens. And it says here, atoms will bond if the molecule that forms, remember a molecule will be a combination of 2 or more atoms, so if the molecule that forms has a lower energy, a lower potential energy, than what the separate atoms have. Okay, so separate atom has an energy, a potential energy. Separate atom has a potential energy. You add those two energies together, you get a value. If they form a bond and that energy of that combination is lower than what it would be separately, then they will want to form the bond. The reason why is because the lower the potential energy, the more stable. So sometimes it's more stable for them to be together than for them to be apart. And I briefly did mention bond energy and bond length, but again, we will get into that in more detail in another video. And this is what the graph looks like. So the potential energy graph versus the distance between the nuclei. Again, check out the links in the description box below for more videos on this. But I just want you to have a basic understanding of what you can expect in this playlist. So this is what's coming up. So atomic combinations, chemical bonding. So what we did is we just defined a chemical bond, and now you understand why a bond happens and a brief description about how it happens. Other things that will be coming up are, so firstly, different types of chemical bonds, Lewis dot diagrams to represent covalent bonds. This is very, very important. You need to know how to draw different types of Lewis dot diagrams, and I'll be showing you how to do that. Graph for potential energy versus distance between the nuclei, briefly discussed in this video, but we'll go into it in a lot more detail. And related to this will then be bond energy and bond length, and how these two things vary with different sizes of atoms and things like that. Then we'll be looking at molecular shapes using this model, electronegativity and change in electronegativity, and flowing from that. So based on that, we work out the polarity of bonds using difference in electronegativity. And from that, we use that information to help us determine if a molecule is polar covalent or non-polar covalent. All of these things fit together. So all of these topics flow from one to each other. So you need to watch the entire playlist. Make sure you go through all the different subtopics, because if you're missing a piece of information, then the next subtopic won't make sense. I'll see you in the next video, everybody. Bye.